So this is a solution presentation for problem H, high score, at NWork 2017. So this problem is about computing scores in a game called Seven Wonders. So in this scoring aspect you are given 4 integers, which we call A, B, C, and D. The score we try to compute is the square of A plus the square of B plus the square of C, plus the minimum of A, B, and C times 7. However, we are allowed to increase numbers A, B, and C by at most sum D. So the first realization is that the sums of squares and the minimum are quite different aspects of the problem. So if we knew what the minimum of A, B, and C were, we know how much we need to increase numbers with. So if we first do this guess, then we really only have to care about which of the numbers A and B should we increase. So here it turns out that the optimal strategy is to put all of the remaining increase on A. So why is this? So assume that you have your numbers A, B, and C with some given minimum. And it was apparently optimal to put some at A, but also some at B. However, if we increase A by 1 and decrease B by 1, our difference will be 2A plus 1 minus 2B plus 1. But since A was the larger one, well, we have that this increase is actually positive. So we might just as well put everything on A. So the second question is, how do we know this minimum? It turns out that this is actually quite easy to brute force. So if you consider the case where you have 3, for example, distinct numbers with C lowest, if you increase C by 1, so that you increase the minimum, you will get 7 extra points because of this increase, plus 2C plus 1 points because of the increase in the C squared. However, if you instead increase A, and A is, for example, 5 units larger than C, the increase of A would actually be larger than this increase in C. Which means that if you try to extend the minimum by more than, for example, 5, you might just as well have extended A from the start instead. And the corresponding case applies if you want to increase both B and C.